Let's look at this graph here. So first we want to see where f is increasing and then decreasing. So it's good to draw a number line first, the first derivative test. And we're going to put in our critical points. So we're looking where the graph is 0. The derivative is 0, so that's at -2, 0, and 2. Function is decreasing, then increasing, decreasing, then increasing. So it's just alternating. Okay, so it's increasing from -2 to 0 and 2 to 4. It's decreasing in between, so -4, -2, and 0, 2. Let's look at the absolute maximum. We're looking at the highest y value, which happens to be over here. So that's a -4, 2. For the local maximum, well, we're interested here is changing from increasing to decreasing. So that's obviously at 0, 0, 1. And then here it's increasing, and we're only going to do it one-sided. So we're going to include the endpoint as well. So that's going to be 4, -1. Now the absolute minimum, we're looking at the smallest y value, so that's at 2, -3. And the local minimum, well, that has to change from decreasing to increasing, so that's at -2 and 2. So that's -2, 0, and 2, -3. Okay, and that completes the problem. Let's move on to another one. Okay, so this one we're going to draw out the number line. So first, where the derivative is 0, we'll say that's about -3.25. Let's see, -1.5. It's undefined here at 1, and 0 again at 2. Okay, so it's increasing, decreasing, increasing, decreasing, increasing. So pretty much a standard alternating. Okay, so it's going to increase from -4 to -3.25, -1.5 to 1, and 2 to 4. Decrease everywhere else, so that's -3.25, -1.5, and 1 and 2. There's an absolute maximum. Well, the absolute maximum is the highest point of f of x, which is at 4, 2. For local max, the function has to change from increasing to decreasing. So that's clearly at -3.25 and at 1. Okay. And next we want the absolute minimum. We want the smallest y value, which is over here. So that's -1.5, -1. For the minimum, we want it to change from decreasing to increasing. So that's over here. So it's negative 1.5 and 2. See, and then let's see, negative 1.5 and 0. So we also want to include the endpoint here, because to the right it's increasing. Okay, so this is a local minimum. Okay, let's go on to the next one. We'll draw out the first derivative test. So it's here. It looks like it's 0, but it's not exactly 0, so we're not going to include it. Negative 1, it's undefined. A half here, undefined, and 2, it's not continuous, it's undefined. Okay, so it's increasing, increasing, decreasing, increasing, increasing. Okay, so yeah, this is just going to alternate. Okay, so increasing from negative 4 to negative 1, 1/2 to 2, 2 to 4, decreasing negative 1 to 1/2, and there's the absolute maximum. So that's going to be all the way up here at 4, 3. A local max. Okay, so that's increasing and decreasing. So that's a negative 1 and 2. Absolute min. Well, it would have been this one, but it's not defined there, so there's no absolute minimum. And then for the local min, this one we're interested in decreasing to increasing. So that's clearly at 1/2 here. And then also over here, so that's the endpoint. Oops, negative 4, negative 1. Okay, last one. Okay. So we'll draw out the first derivative. Function, let's see. It's not continuous at negative 1, so this looks like it's an asymptote. And 1 as well. Or not, 1 is, sorry, not an asymptote, it's a jump discontinuity. And at negative 2.5, it's 0. So here, we'll just edit here. And then at 3, it's 0 as well. And it's increasing, decreasing, and then it's just alternating. Okay, so we'll say it's increasing from negative 4 to negative 1, 1/2 to 2. Wait, actually, a mistake. Negative 4 to, let's try this again. So increasing from negative 4 to negative 2.5. Negative 1 to 1. And 3 to 4. Now it's decreasing everywhere else. So we said that was negative 2.5 to negative 1. and 1 to 3. Here there is no absolute maximum. It would have been this point over here, but it's not filled in. So you can always get bigger and bigger. So it'll be like 2.99999, keep going like that. It's not a nice defined number like 3. So for the local max, let's see, we want it to be changing from increasing to decreasing. So yeah, it looks like over here, -2.5. And then at 1. And then at the end here. There is no absolute minimum. As we can see, this goes on forever. So, technically it would be negative infinity, but yeah, that's not a number. And then finally, the local min, we need to change from decreasing to increasing. And that's going to be at -1, 0 and 3, 1. So that completes the problem.